Hi, my name's Simon Elliston Ball. I'm a product manager for cybersecurity. I'm going to tell you a little bit about the power of behavior profiling in Apache Metron. So, in Metron, we have a number of data flows, but the primary one is really this process by which we parse all the data. So we bring it all in, we make it all nice and neat so we can work with it. We then move on to enriching that data. And what this is about providing a lot of context to that information. So things like enriching the GUIPs, finding out where IP addresses come from, DNS lookups, reputation scores, those kind of things. We then move on to index that data, and that puts it into a variety of different data stores, which gives us the ability to query later. However, the other thing we do with the data, and by that I mean all of the data that goes through the Metron pipeline, is we push it down to a very important part of Metron, which is the profiler. And that's what we're going to look at today. So, what does the profiler actually do? As I said, it receives all of the data which goes through Metron. So let's give it a few sample data streams. If we start off with my timeline there, we might start off with something like web proxy data. So we get a lot of user requests coming in, and we'll just dot a few of those around. They're changing in frequency over the day, but reasonably consistent. We then might have, say, a stream of DNS data. So let's take slightly fewer of those. Maybe it's just for our web browsers. So we'll take a little bit of DNS data, and that again will go on through the day. We might then have a third source in this instance, and we're going to take something like the authentication data. So here we might have something that's a little bit different, a little bit of a mix of different data types here. So we have, say, log on events, log off, a few more logons. Let's say this is the beginning of a day. We probably have more logons at the beginning of a day. So we'll have a few more of these, and maybe people log off around lunch. We'll have, and then these kind of tail off during the day, maybe a few little odd events over there. So what we then do with the profiler is we chop this up into a series of time windows. So we're going to start with the beginning of the day and maybe chop our time windows. We usually have windows about every 15 minutes. Some people use 5 minutes to get a little bit more granularity. And so far, so much like any other streaming system, right? Every streaming system under the sun provides some sort of window time analytics. What makes the profiler different is that it then, out of each of these windows, at the end of this, produces what we call a data sketch. So for each of these time periods, we're producing one of these data sketches. Now, an important part about these data sketches is that they are all the same size. And what that means is that they are very predictable. So it doesn't matter if I have 1,000,000 messages here, or 1,000 messages here, or 10. These sketches are going to take up the same amount of disk, they're going to take up the same amount of compute, which means that I can be very predictable about how I scale them. That means that I can also personalize them to quite a great degree. If I have 1,000,000 web requests for one user, it's going to take up the same 2.5K for a structure like hyperloglog that it would for 10 users. What that means is I can then store these nice small approximate data structures into something like an HBase table. So we'll put those into HBase, and we'll come back to why we want those there shortly. The other thing that we can do with these structures is to take results of them and push them back round from these profiles into the rest of the Metron pipeline. So we have profile results which are coming back round and being enriched again. That allows us to generate alerts from them, from particular changes in behavior, for instance, but also to profile them. So we can profile the profiles. So even if we have a profile here which is counting something like, let's say, the number of unique items or the number of unique servers that one of our users here has logged onto in that time period, we can then provide a more statistical baseline to that by reprofiling that. So we have another feed from these profiles along time, and you'll see that what it's doing is it's writing one out at the end of each of these time window periods. In fact, it's probably actually running a few of those out because we've got one for each user or for each server or for each domain name that we want to push through. So we have this little cluster of profiles that we're collecting over here. What we can then do is turn those into profiles of their own. So we can produce a different type of profile out of that, a different type of data sketch. But in this case, we're going to produce something like a T-digest data sketch. And what that does is to approximate the distribution of that data. So we can look at how it changes over time. And maybe this will be a different kind of shape as we move through the day. We might have a nice sort of normal picture in the middle. So I have a baseline for my main profile. However, what we then need to be able to do is use some of these things to generate real alerts and figure out whether new messages that come through the system are within normal or whether they're an anomaly. So the way that we do that is by, in our enrichment rules, being able to pull back these profiles from HBase. So another key property of these data sketches is that I can combine arbitrary ones of them. So I might be able to say, pick back the data sketches from the last week or for the last 6 months, but maybe I only want the ones on weekdays, and maybe I only want the ones at the current hour of the day, so that I've got a good comparison for normal behavior for that time of a working day, for instance. But I also want to be able to skip public holidays. With a profile windowing capability, I can do that. I can pull back arbitrary members of these profiles and combine them. So I could say, I want that one, and I want that one, and I want that one. But I don't want that one because that was a public holiday, right? So I can then combine those into a common baseline, which I can use as part of my enrichment, as part of a real-time stream, to be able to calculate whether my new messages are anomalies or whether they're just normal behavior for a user. That allows me to do some quite interesting things like automate the alerting of strange and anomalous behavior. And that is a big part of the power of profiles. So thank you very much.